Next up, representing both Quasar Science and Litepanels is Timothy Kang. Timothy is a cinematographer, and would also say a color scientist. Is that fair?
An engineer. I know color scientists, and I'm not nearly
If
that
you're going to
level.
talk, you have to be up here.
Yeah, I'm not really at the level of a lot of color scientists I know, so it's hard for me to say that, but if people want to call me that, it's hard for me to say no.
Anyway, Tim always makes a great presentation, so take it away, Tim.
Great. Thanks, Jim. I wanted to take the next, I would say it's about like 20 minutes that I have here, since it's two sections. Jim always wants me to present not just product, but for my own personal conviction as a cinematographer, I try to always present stuff that pushes the craft of what we do in the business forward. So a couple of years ago, I walked across the street from Quasar HQ, and there was a company called Lux Machina, if you don't know who they are. Lux Machina is a consultant company that started doing something with LED volumes before anyone else was talking about LED volumes. And I saw what they were doing, and I was like, well, I gotta join this because it's gonna take over. And this was 4.5 years ago, I believe, already. And I already saw a lot of the issues that were gonna come out of it ahead of time as a cinematographer. So what I'm presenting you today is really 4 years worth of experience of seeing all this stuff happen, seeing all the issues, and pretty much an exhortation for everybody in the industry to understand what I'm talking about here, not just for Quasar and light panels only, but as an industry as a whole. So just a little bit of myself. I'm a cinematographer, I went to AFI, but I also have an engineering background. I studied biomedical engineering at Johns Hopkins. I did 7 years of biomedical research, and I have a couple scientific papers published with my name as a co-author, so I am a true nerd. But ultimately, that was not my calling. My calling was filmmaking and storytelling. So I went to AFI afterwards, after all that, because that's really where my heart is. So what I want to talk today is something called on-set image-based lighting. And what I am going to present, this is what is really true motivated lighting for filmmakers. So what is on-set image-based lighting back then? What is it now? And how can you do it, or how can I do it as a filmmaker? Why does it matter? So that's what this talk will be about. So image-based lighting, in the past, used usually these elements classically. We had a light source, we had a variac or some sort of dimmer, or you had gobos that you moved around either by Hollywooding flags, or if you're more sophisticated, you had something on a motor, and you had some sort of gels involved to change the color, right? So let's say we're doing a TV gag. You would have 4 fixtures blended through a diffuser, and you randomly turn them on and off, and they were like maybe daylight balanced or something to give you that daylight feel, right? That TV feel. Poor man's process. I mean, we've all done this. Most of us probably have done this in a room where you're moving physical lights around. You have a backdrop, or you have a video screen doing rear projection, or you're doing a fire gag with multiple point sources with gels, and you're trying to turn them on and off randomly using a magic gadget or some other sort of dimming, like an automatic dimming flicker box of some sort. And I'm sure everybody's done this at least once in their life in this room. So now things have progressed as history progressed. For example, Roger Deakins, he liked doing things simply, right? If you read any of his articles, he will talk about how his producers love him because he loves doing things on a very simple level, is how he says it. Well, this is his simple fire gag, which is obviously not simple to rig, but the concept is simple, is that instead of doing a burning house with just a single source light, he built a wall of dinos, and he animated fire onto the wall of dinos, right? And this is, maybe almost 10 years ago at this point. And then when he did 1917 with the burning church scene, you have a bigger wall of dinos, essentially. And as you can see, it's very simple, right? Now, obviously, it's not simple, but the issue here again is he is taking an idea of, he's got an image of fire, and fire is not a static thing, it moves, right? But let's kind of take a step back. Where else has where else have images started playing into the world of lighting? Well, process work has started to use video screens of certain sizes, and this is again maybe 10 years ago before House of Cards. This is how it started developing, right? How do you use video screens to light car scenes, right? And then it got to a point with Rogue One, Greg Fraser, who was one of the pioneers of bringing it into our world. This is a massive screen to be the hyperspace, scenes. So that's a small historical context to this, right? Now, when I use the term image-based lighting, though, it's not just putting video onto light, right? There's an actual serious academically based technique, and this came from the CGI world. Now, basically the way that image-based lighting worked is that you had, you took a 360-degree photo, right, that had all the light data in the room from the perspective of your subject. So whenever you see the VFX folks with their balls that they like to play with on set, you stick the camera there. That's where the subject is. And those balls are basically used as references for lighting, and the scene references of what the scene actually is, that's lighting that object, right? So you put a 360-degree camera there, get all the lighting data, you do multiple bracketed exposures, and then in the virtual environment, you take a virtual globe, you put it around that subject, and you map that 360-degree photo onto that sphere, and you get a reflection of the world now on it. So it looks more realistic. And then on top of that, not just for reflections, then you start describing the different parts of the image with certain light qualities, and then you get both the reflections and a photorealistic lighting scenario, right? So that in a nutshell is what image-based lighting has been. And this guy, who's been on this stage in the past, is one of the main researchers and trailblazers that came up with this concept and technique about 20 years ago. So this is a really mature, serious, PhD-led academic computer graphics technique that essentially 10 years ago started making it onto real sets, right? So this is, anyone recognize what movie this is? Any takers? Gravity, right? So Gravity was the first real, I think, visibly visible example of how they were the first people that put a LED volume around an actual subject. And it's a literal cube of display tiles, and they put video on it, and they basically lit Sandra Bullock and I think it was George Clooney, right? With the world, right? So a couple years ago, 2 years ago, I did a research project with USC and Paul, and we try to do this now that volumes are cropping up everywhere, right? So here is a real-life day scenario of actual daylight, right? This is down in Playa Vista, or somewhere around Playa Vista. This is a rendering of the 360-degree photo that was taken, right? And here is the rendered world on a virtual object, right? So this was done by Weta. So you took these two gray ball, mirror ball and gray ball, and you can see that this is a 3D rendering, but it looks realistic, right? Now, what if we did that in real life? So we went to a virtual production stage up in Pacoima. As you can see here, you've got a curved wall, you've got a ceiling. You can see we're mapping the coordinate system to work so that when I map that into real life onto it, you have a real environment, right? And because there are limitations of this technique in real life with video panels, I had to put a hard light source with something that would emulate the sun in the exact same position from perspective of the subjects. You can see with that the light fixture is directly in front of the sun, right? And I had to, at the time, use my light meter to dial in the exposure to match the same lighting ratio as it was in real life. And as you can see the results here, because this was a stage, the volume now was not the background behind the person, it was the light source with a real hard light. You can start to see that at least the lighting ratio and the contrast ratio and the color differences are starting to match real life. So that's basically where things start to go and have come, right? It's coming to set now. So how does this actually work? Well, let's ask this guy, right? So Ansel Adams, if you're not familiar with him, he's one, besides his fine art history, place in fine art photography history, he's one of the pivotal folks that actually formalized the technical underpinnings of exposure in photography. And understanding the print, understanding the negative, understanding the camera, and understanding light, and how they all, if you saw the entire apparatus of the filmmaking workflow at his stage of history, you can control, as an artist, your final image based off of what you see in reality. So this system was called the zone system, and what he did at the time was say, okay, let's think in terms of tonalities. Every single gradation in the world of doubling of light or a stop of light is a tonality gradation, right? And he split it up into what he called 10 zones from black to white, with zone 5 being the middle of medium gray, right? And I'm not going to get into the weeds here, but essentially everything in between with the negative and with the print was a method of taking all these real life values of light and describing a tonality with it using the technology at hand, right? So you're basically just playing the game of telephone like you did in elementary school, but now you're using real tools that actually don't forget the values, and you just transfer the values from one medium to the next medium to the next medium, so that the final result is you get a certain image that you wanted with a certain tonality that you want. So that's how image-based lighting actually works. And so nowadays, we can do Ansel Adams' zone system in reverse with lighting. So you can take a scene, which is a range of light. You get a video camera, and video camera, or motion picture cameras are video cameras, basically. They've reached this point in history where essentially you could accurately record all the tonalities of a scene and relatively accurately start getting color data attached to the tonality. And there's all this engineering that takes place underneath the hood that you may or may not need to know. But as long as you have a light fixture, a set of light fixtures that understand that language and also understand the language of physics, you could basically create a volume of light that you can construct and map in real life with better tools, that lighting environment that emulates the original environment out in the real world, right? So why would you want to do this? Well, what if you shot on location, right? It was very expensive, and you needed to do pickups. You know, how would you can't go back to the location, but if you had the prescience to do a 360-degree capture while you're doing all these setups and the shoot, then you can go to a lighting volume with some sort of video backing, and you can reconstruct that location to do your pickups, let's say. That's just one tiny example of how this starts playing out in real life. Now, here's a test that I did with my former colleague, or he's still a colleague, obviously. Ben Dynas is a local 728 programmer. So we did what we call a ground truth test, where one of these is a daylight exterior, and one of these is matching the exact qualities of light coming from the daylight exterior with a video plate. And in order to do the tests, there's lighting condition 1 was a 10-foot by 10-foot garage door, and it was at a certain time of day with a certain type of camera orientation. And the second condition was close the door, you blocked all the light out, created an 8-foot, basically an 8-foot light aperture that had the same exact incidence of light from that 10-foot door. And basically I shot a video plate, as you can see here, of that view outside the door. And you can see I lined up that 8-foot wall basically to match the same field of view. Is it coming up? There you go. So now this is the same field of view, and this is a picture I took using my phone, and the color that kind of washed out with my phone of the light fixture. But you can see that it has the same general range of tonality. There were actually cars moving because it was a video plate, but essentially it was the same quality of light. So if we only look at tonality and take color out of the equation, this is the daylight interior, right? And these are, on the top left is the daylight interior, and the other three are the video plate being played out. So this is just to verify that it matches the tonality, right, first of all. And I white balanced it, either just did blank white, or I did the video plate, or I can even white balance the video to a different color temp that I'm shooting at. But when it comes to black and white tonality, you're not going to see any difference, right? Now, if I did a direct color comparison, you're going to see some slight differences, but let's take some notes here, right? If you look at the gray card, this is the real life scenario. A flat white image would not do this. A flat white, this is what gives away a real life scenario, is that you can see the shadow cast by the knuckle on the gobo head. There's a blue shadow and an orange shadow, right? So if I start doing this, now you can see, for example, on where it says 4279 Kelvin, you start seeing that same differences of shadows, of color. So this is where you start getting past that uncanny valley of just a blank white plate, and you start getting into a truly realistic, motivated lighting situation, right? So what I'm going to do now is basically show you this in real life. So I'm going to go to the software here. This is going to be, all right, oh, cancel that, sorry. Open that. Okay. And I think this is going to work. All right. So what I can do is, this is a 360-degree video taken by a colleague in the industry. His name is Alex Pierce. He does VR captures. So he did a VR capture of, this is 2nd Street Bridge at nighttime in downtown LA. And what I can do with this is, first of all, I can spin the world around, right? So if I turn the world around, you can see that it's like the Google Street View, right, of the scene, right? And so you're seeing the reference of the video of where we are in the world, right? And what I can do is, if I start doing lighting plates, I don't need to kludge together some sort of fake chase. Now I can move this sample and say, any part of the world I want to be my key light, or whatever light that I want to be, I can map it to the video. And this is basically where the industry has been heading. And if you're not doing this, you will be doing this. And this is not just a state-of-the-art thing. This infrastructure has actually existed to be able to do this on the software side, on the lighting console side for decades, actually. It's the lighting fixtures that haven't caught up, and now they have. So this is basically what I did for the past couple of years. What we did at Quasar the past couple of years is I focused on color science, my colleague focused on the light data language, and we basically created the context to be able to translate real world light data captured by camera and using these images to drive your lighting. So this is, again, this is Quasar, this is light panels doing this, but ultimately you can start, what we did, I started the lighting committee at the ASC as an associate member. I'm trying to push the industry, all the lighting companies basically to understand that they have to push their fixtures to go in this direction well, because it's an ecosystem, right? We all have to work together because ultimately it's about the art and it's about storytelling. This stuff actually, like this software costs 10 grand. It's actually for a stage to buy this. This is just one example of software. That's peanuts, because if you start, it'll amortize really quickly. So think about how much it would cost to do this practically. You gotta get the police escort, you gotta do you have to get the permits, street permits, you gotta do lockdown, and then you have to do the shoot. I mean, you've done process work. Process work exists because it's expensive. It's called poor man's process, because actual process work on the streets is really expensive, time-wise, stress-wise, safety-wise, et cetera. The cost savings are on time, on money, and also just on livelihood. So yeah, it's a lot less. Yeah.
But what about the cost to actually go out and film the lighting in order
Yeah.
to program?
I mean, you
Comparing the cost to,
yeah.
I think,
You can do location, you can have some sort of second unit person do it. I mean, it's a single camera car, or you can even, on a super budget level, you can take one of these 360 cameras, stick it onto the top of your car with a suction cup, and just start rolling camera and drive around town. And I've done this many times already for doing normal rear projection work. So the workflow has already been done in terms of how do you do rear projection plates. It's the same, if you start looking into that, it's really not that expensive.
and
ultimately. Yeah.
correct me if I'm wrong, but a big difference is that you have to do a lot more in pre-production. You
Yes.
can't just show up on the day and shoot. You have to
Right,
plan
yeah.
it, you have to shoot
Which
your
is what you should
backgrounds
do anyway.
in advance. Yeah, yeah. So it just moves part of the process. It's probably less expensive in the end.
Yes.
But you're pushing part of the process
You're pushing the process
into pre-production.
in pre-production and not fixing in post is the idea here. So
I'll have to thank Tim with that. Thank you so much. Great presentation.
thank you.